Cosine prime. Very good. Copy the second function. Plus cosine, and now careful. I have to differentiate natural log. This one. How do I differentiate this? 1 over whatever I covered here times whatever I covered prime. One over x. What can be done? Nothing. Just multiply both sides by y. So then dy over dx equals, we had natural log x raised to cosine x, open brackets, negative sine x natural log of natural log x, plus, and you can condense this into one fraction, cosine x over x natural log x. And this is it. Any questions? Any questions, please? Yes, Vanessa, please. So till this step is clear?
Oh yeah.
So I'm multiplying both sides by y.
So that's the element, natural log x to cosine x.
Yes, so this is, because they are multiplied, this is 1 over 1. This times this is here.
Yeah.
This times 1 times this is here.
I understand. I'm talking about the first part.
Oh, this one?
Before that.
This one?
Yeah. Like how do you know? Like, how did you get that?
So this is like having 1/2 times dy over dx. In order to solve for dy over dx, I have to multiply by 2. So I multiply both sides by y. But instead of writing y, I copied the function.
Okay.
That was our original function.
So you just copied the original function?
Because I'm multiplying both sides by y.
Okay.
I was just lazy.
Okay.
I should have written one more time, dy over dx equals y in brackets, and then write one more time and replace y by this.
Okay.
Instead, I said, okay, do we agree with this? And if you had said no, then I would have written one more step. It's not your fault. Any questions? Okay. So once you start practicing these problems, if you want more problems, we're going to look at more functions to differentiate using logarithmic differentiation. And you picked that problem very nicely. It was good practice. I'm not going to ask you to apply natural log or use logarithmic differentiation on the product. No, you do whatever you want, but I think it's longer, but we should have seen that one, at least one problem. Very good pick. Okay, 3.7, word problems. So we looked at a lot of theory, and we looked at a lot of differentiation and logarithmic differentiation, etc., etc., etc. What do we do with this? Okay, so let's start with a simple situation and work our way up. So I would like to choose a problem with motion. So we have several problems with motion here. If you pick the odd number problems, then the answer, yeah, I would have to pick even number problems. So let's pick even number problems for me, and we pick odd number problems for you to check the answer. So let's do 8, okay? If a ball is thrown vertically upward with a velocity of 80 feet per second, then its height after t seconds is. So we are given a function. So this is 8 on page 234. And s, I like to write s of t, because that's what it is. It's a function of t. 80t minus 16t squared. I think you're going to find the applications easier than the big theory and sophisticated functions. Okay. T is in seconds. We always have to write that. I'm taking notes when I read a problem. And height s in feet. Because, as you know, an answer without measurement unit doesn't mean much. Please. Okay. What is the maximum height reached by the ball? Part A, max height. First of all, let's look and identify the type of function. What type of function is 80t minus 16t squared? And you know me, I don't like anything that is not in descending order. It is quadratic. Excellent. So a quadratic function, we know now for a long time, right? It either has a minimum, just one minimum, or it has a maximum, just one maximum. Good. So we're asked to find the maximum height. I can think in terms of algebra. And I find the vertex as negative b over 2a. But we're done with that. We know more than that. So if this function has a negative leading coefficient, it's quadratic with a negative leading coefficient, I know it must look like this. No question, right? Negative leading coefficient, it has a maximum. So what about the slope of the tangent line at this point? Just give me sign. Excellent. What about here? Give me just the sign. But what about here where the function has a maximum? 0. So what do I have to find? And set it equal to 0, the derivative. So let's find s prime of t, which is negative 32t plus 80. And what do I do with it? Because this is the function that will give us the slope everywhere, including at that point. But I know that the slope at the peak must be 0 or maximum. So all I have to do is write s prime of t equals 0. Negative 32t equals negative 80, of course. So t equals 80 over 32, and I have to simplify. And this is in seconds, because t is measured in seconds. So I'll simplify by 8. And what do I get? I get 10 divided by 4. And I'll simplify by 2. And I get 5/2 seconds. The question is not asking us when the maximum is attained, but how much it is. How much is it? How do I find how much it is? Plug that in the function. Very good. S of 5/2. 80 times 5/2 minus 16 times 5/2, everything squared. And you know me by now, this is what I'm going to do. I'm going to go to the graphing calculator and punch it in the graphing calculator. Who knows, I may want to determine other things. So I'm just going to punch in negative 16 x squared and plus 80 x, and go to second in table. It's always, sorry, I have to adjust that. So I want to plug in 5/2 or 2.5. It's 100. So the maximum is 100 feet. Part B. What is the velocity of the ball when it is 96 feet above the ground on its way up and then on its way down? So part B, find velocity of t when s of t is 96 feet. So now let's analyze what we're given. We're given in this problem the distance formula. How will I find the formula or an expression for the velocity? What do I know about the velocity? It's the rate of change of with respect to time. Excellent. So then how will I find v of t? It's indeed s prime of t, which we already determined, negative 32t plus 80. So we are asked to find this when this happens. Well, what am I missing? I'm missing the time. Very good. I'm missing the time. So then I have to solve this equation for the time. So the function was negative 16t squared plus 80t equals 96. So we're asked to find the velocity at the moment where the ball is crossing the altitude of 96. So we know that this is the trajectory of the ball. We know that this height is 100 feet. We know somewhere here is 96 feet. So obviously, at this point, this slope is the instantaneous velocity at that point. That's what we are going to find, the slope of this line. And then at this point, the slope of this line. So what sign do I expect on this side as it's going up to reach the maximum? What sign? What sign here? It doesn't mean that the velocity is positive or negative. It just means that it's the direction. Going up is positive, coming down is negative. Not that the ball has a negative velocity. Okay, perfect. So then how do I solve this? Very good. So first of all, I'm going to try and see if I can get rid of all those big numbers. I'm not sure. We'll see. So t squared minus, how much is 80 divided by 16? And then this will become negative, but I divide by negative. So this is negative becomes positive. This is positive becomes negative. This will go to this side negative, but I'm dividing by negative 16. Okay. And this is very clear now. How do I factor this in a blink? Very good. T minus 2, t minus 3, which means there are, as expected, two different values of t. What are they? 2 seconds and 3 seconds. So from the launching side till this point, what is the distance? Forgive me, what is the time? 2 seconds. What is the time from here till here? 3 seconds. We're not asked to find the time, but we had no choice. We're asked to find the velocity when the time is 2 seconds and 3 seconds respectively. So what do I need to do finally? Plug it in. Plug 2 in here to find the velocity, plus plug 3 in here and find the velocity. Do you expect the velocities to be the same? Just opposite signs. Very good. So please plug in 2 and please plug in 3 and tell me what you get. So V of 2 and V of 3. V of 2 will be negative 64 plus 80 and negative 96 plus 80. The first one is 16 measurement unit. No. No. Feet per second. Very good. It's the rate of change of distance with respect to time. And this is negative 16 feet per second as expected, because this is on this side, it's negative, and this is on this side, it's positive. Any questions on this problem? Any questions on this problem? Okay, so here's another wonderful application. Let's take a look. Problem 18, and let's read it. If a tank holds 5,000 gallons of water, which drains from the bottom of the tank in 40 minutes, then Torricelli's law gives the volume V of water remaining in the tank after 10 minutes like this, between 0 minutes and 40 minutes. Yes, any questions? Cell phones, I see. Wonderful. Find the rate at which water is draining from the tank after 5 minutes, 10 minutes, 20 minutes, 40 minutes. At what time is the water flowing out the fastest, the lowest, and summarize your findings. Ready? What do we start with? Of course, we have to copy the function, the law, Torricelli's law. Okay, 18 on page 234. Is this exciting or what? Yes?
Maybe.
Good. I take maybe. So again, this is V of t, 5,000, in parentheses 1 minus 1 over 40, t everything squared, and T is between 0 and 40. And volume is in gallons. Have to write all this. And T is in minutes. Okay, anything else? Find the rate at which water is draining from the tank after 5, 10, 20, and 40 minutes. And then we'll answer the rest. So T, 5, 10, 20, and 40. Just making sure I copy this. Yes. And then we'll respond the rest. Okay, ready? What are we asked to do? What are we asked to determine? How do we start? Yes, Nathan, go ahead.
I took the derivative.
Excellent. Well done. Thank you. So V of t equals, we bring down the power, so 10,000, 1 minus 1 over 40t, subtract 1 from the power, times the inner function prime.
Over 40. Negative.
Right. Negative 1 over 40. I'll simplify just a little bit. 1 0 with 1 0, and 1,000 divided by 4 is 250 with minus in front. 1 minus 1 over 40t. You can distribute it. I recommend that, or not. It doesn't matter. We just have to determine these numbers. I will put this function in and just plug in the numbers. So if we do simplify, then I have 25 over 4t and minus 250. Right? Negative 250 divided by 40, by negative 40 I should say, it's 25 over 4 but plus. And then negative 250 times 1 is this. This is the function we have to plug in. Say it again. So negative 250 times negative 1 over 40. I simplify by 10 and I get 25t. And then negative 250 times 1 is just negative 250. Of course, I will put this function in the graphing calculator in y equals. I'm not going to do this by hand. So this is 25. Don't forget parentheses. 25 divided by 4 because if you by 4. If you don't put parentheses, the calculator will do something else. X minus 250. And then second and table. And we want 5, 10, 20. What do you expect to be at 40?
0.
Exactly. There is no more water. It must be 0. If the tank empties out in 40 minutes, of course. Good. So I will put those numbers in. Why are all these negative? Because it's in the change is negative. Yes, it decreases. When we looked at the previous function, when the volume decreases, the rate of change will be negative. Excellent. Very good. Well done. So I copy the numbers. So I wanted you to tell me what to put in here, but you already did. Of course, it's V of t, which is the rate of change. Instantaneous rate of change. At 5, we got negative 218.8. At 10, negative 187.5, negative 125, and 0. Excellent job. Now, part B. At what time is the water flowing out the fastest? At what time is the water flowing out the fastest? What do you think? At time equals from anywhere between 0 and 40. At 0. At 0. So if we plug in 0, correct. So the moment you have a balloon and you punctured the balloon. Or you just, and it does not just blow up, right? So it decreases its volume in time. What is the fastest rate of decrease? Right. at the very initial moment. Very good. Okay, this was, at what time is the slowest? When is the slowest? So I will write max rate at t equals 0 minutes. That's the max rate. And what about the slowest? We already know. At 40, very good. Slowest min rate at t equals 40 minutes. Perfect. And summarize your findings. We already did summarize our findings. Any questions on motion problems and volume problems? And I have one more type that I would like to go through. Any questions on this? Okay, so here is one more type that I would like us to discuss and understand. A particle moves according to a law of motion. The law of motion is given in our problems. T, of course, is time greater than or equal to 0. T is measured in seconds and S in feet. I'm going to copy that information in a minute. Find the velocity at time t. What is the velocity after 3 seconds? When is the particle at rest? When is the particle moving in the positive direction? Find the total distance traveled during the first 8 seconds. Draw a diagram. We'll discuss that in a minute. Find the acceleration at time t and after 3 seconds. Graph the position. We'll do that. When is the particle speeding up? When is it slowing down? A lot of work.
Wow.
Okay, good. I'm glad you're excited. So we start from scratch. Yes, it's page 233. You're going to have a problem like this to work on. So let's start. Well, let's do 2. One more time, page 233. And then you will work on another, like 1 or 3. Okay, so we are given f of t, which is 0.01 t to the 4th minus 0.04 t to the 3rd. And this is the law of motion. S is in feet. So this is in feet. And t in seconds. Of course, one is distance and the other one is time. Find the velocity at time t. Part A. Velocity at time t. I know we only have 9 minutes. We may not be able to finish it in 9 minutes. My apologies. We'll continue on Thursday. So, this is very important, so I'm going as slowly as possible. So v of t is f prime of t. So if you want to call it s of t, you can. Same thing. Very good. So this is 0.04 t to the 3rd minus 0.12 t squared. I copy all the zeros? Yes, I did. And that is part A. Any questions on part A? Is this okay? Part A okay? I bring down 3 and subtract 1 from the power. I bring down 4 and subtract 1 from the power.
Okay.
And I have to multiply by 0.01. Is that okay, everyone?
Yeah.
Okay, perfect. Part B, they say, what is the velocity after 3 seconds? Of course. So V of 3 will be 0.04 times 27 minus 0.12 times 9. I'll use my hand calculator this time to see what this is, because I'm lazy. Minus 0.12 times 9. Correct me if I'm wrong. I got 0. Please correct me if I'm wrong.
Wait, are you finding velocity after 3 seconds? Or...
Yes.
Okay.
V of 3. 0.04 times 27 minus 0.12 times 9. Yes? Did we get 0? Did anyone else get 0? Yes? Feet per second.
Yeah.
It's very possible, which means that the particle is at rest, right? If you're not driving, you're sitting in your car is idle, right? Or you are at rest, right? Velocity 0. Any questions? Part C. When is the particle at rest?
3 seconds.
I don't know. I don't know. What do I have to write? When is your car at rest? When the, Savannah? Thank you very much. So here's the velocity, 0.04 t cubed minus 0.12 t squared equals 0. What type of polynomial is it? What type of polynomial is this? Degree 3. How many solutions do I have to write? 3. Even if they're all the same. I still have to check. Good. What is the first step? I would like to divide, yes, but I would like to divide by 0.04. So then t cubed minus 0.04 times what is 0.12? Very good, excellent. This is more human, I would say. And yes, now I can factor out t squared. And you have to give me 3 solutions. Why? Let's write next to it. Degree 3, 3 solutions. It's a must. Good. So t equals? Perfect. T equals another 0. And t equals 3 seconds. So now we know for sure that this function, or forgive me, the particle, is at rest in 2 different points with t equals 0 and with t equals 3. That's why I said, yes, this is fine. However, I cannot decide or conclude that this is the only one. That's why I have to take it easy. Part D. When is the particle moving in the positive direction? So remember the throwing of the ball up in the air, right? So we can consider that the particle is going up or down. Or we can consider that the particle is going to the left or to the right. To the left would be a negative, so it's going back. To the right would be positive. But let's explain going up and down because it's somewhat easier to understand. When the ball was going up, the velocity had the sign positive. Then it had 0 because it has a maximum. And then decreasing, which means it had a negative sign. So we are either considering that the particle is going up with a positive sign and comes back with a negative sign, or you can say it's going to the right with a positive sign and coming back with a negative sign. The velocity, the sign of the velocity will tell us what the particle is doing. So t was greater than or equal to 0, of course. The velocity, you will see how this continues in chapter 4, this idea. And we said that the velocity was 0 at 2 different points, correct? So the velocity is 0 at 0, and the velocity is 0 at 3. Let me copy the velocity function because I went to the next page. What was the velocity? The velocity was 0.04 t cubed minus 0.12 t squared. Thank you. So now I need to study the sign. Study the sign of v, not v prime, sorry, just v, or s prime. The study of v of t. The sign of v of t, that's what we are trying to do. So one way would be to simply pick a number between 0 and 3, like 1, and plug it in and just give me the sign, and another number between 3 and infinity, like 10, plug it in and give me the sign. So if we plug in 1, which of these two is bigger? Well, obviously, this one will be bigger, right? 0.04 minus 0.12 is negative 0.08. So the sign of the velocity between 0 and 3 is negative. Now let's plug in 10. So this will be 1,000 times 0.04 will be 40, right? So V of 10 will be 0.04 times 1,000 minus 0.12 times 100. So this will be 40 minus 12. I don't care for the number. I only care about the fact that the velocity beyond x or t equals 3 will always be positive. What does that mean? And I'll stop. Then this is what I remember where to continue from. What does this mean? It means that between the particle starts at 0, 3 seconds pass, but he's going backwards. And then when 3 seconds are over, then the particle continues to go to the right, to the positive direction at all times. So this is the negative direction. Between 0 and 3, negative direction. We can just put a parentheses, it's fine too, it's a trend. And between 3 and infinity, always positive direction. Here because the velocity is negative, and here because the velocity is positive, which is the first derivative of the function.